All right, I just want to make sure I clarify this idea that I presented in the last video. This porosity. It's basically how porous a certain amount of soil is, and it really has to do with how much groundwater um, can can be stored in that particular volume of soil. All right, and so it has to do with various things. Um, Anyhow, let's take a look at this. Greater porosity equals more potential to store greater amounts of groundwater. Okay, that's the overall idea. I mean, this is technically what it is. It's a ratio of a certain amount of volume, so the open space in the soil or rock, divided by the total volume of the rock, including the space. It's basically like the amount of voids divided by the amount of voids plus soil, right? So anyhow, um, so different things affect this idea of porosity, and it's for example the particle size, the shape, and the sorting. So soil with rounded particles of similar size have higher porosity. In other words, they'll store more water because they're roughly the same shape. The water, the same size and the same shape. They kind of close in the water, and they'll hold it better. All right. And then, of course, if you had various sizes of rock or whatever is making up the soil, then you're not going to have as high of porosity. All right. So, and in the last video, I was talking about how easily it is for water to flow, the groundwater to flow, and that's really a measurement of what's called the permeability. Okay, so this idea of permeability is really that's kind of what I was getting at, not porosity, right? Porosity is just how much water the soil can store. All right, so factors that influence the storage and movement of groundwater, that's what this is. It's the degree in which the groundwater can flow through porous material. Obviously, if it's extremely porous, then it's just holding on to the water. High permeability, greater potential for fluid flow. All right. Sediment packing and connectedness of the pores influences permeability. This leads to this idea of hydraulic conductivity. In other words, how does the water flow? That's basically all that means. Hydraulic conductivity is a measurement of the permeability, and it tells us the degree at which the materials can be transmitted. They can transmit water. All right. So this hydraulic conductivity is a measurement of the soil, or whatever the groundwater is passing through. I mean, I think of soil as little particles of dirt, but it could be rock. It could be rocky material as well. All right. Water beneath the ground exists as groundwater and soil moisture. Okay, so groundwater occurs in what's called the saturation zone. The saturation zone is below the soil moisture. All right, so we'll take a look at the picture from your textbook of this in just a moment. So soil moisture is above the saturation zone, and it's so all the pores are not filled within. There's some air in there, and where the water table, you might have heard that term before. The water table is the boundary between the soil moisture and the saturation zone. All right, so that's it's basically the top of the saturation zone. That's what that is. All right, here let's take a quick picture. Let's take a look at it through a picture in your textbook. Let's see, did I already open it to this? Yes. All right. So right here, right. So this would be This is just showing you a blow up of the soil underneath the ground. And so the shaded area is the saturation zone. And right at the top of that, that's the water table. Right. So that's what that's called. And then where it's unsaturated, so this is right below the surface. You can see they're kind of showing you here that there's still space. There's still three-dimensional space for water to fill. Whereas, in the saturation zone, it's completely filled. Just a kind of a side note, that when you dig a well, for a water well, you want to dig into the saturation zone. That's if you dig only down to where the soil is moist, you don't get the water flowing the way you need to. So if you want steady water coming down out of your sink, anyhow, you always want to dig into the saturation zone, and that's different depths. Like in the deserts, the saturation zone is much deeper than in where it rains a lot, like in rainforests, for example. In rainforests, the saturation zone is going to be much closer to the surface. All right, so let's go back to our PowerPoint. All right, so I think it's better to look at a picture of that to see what the water table is all about. All right, the depth of the water table varies with precipitation and climate. Zero is so zero water table would be like a marsh or a swampy area, where you have the water sitting right there on top. All right, let's see, and then for deserts, you could be hundreds and hundreds of meters below the surface below the surface before you get to the water table. All right. Because even in the deep deserts, no matter how dry the deserts are, there's always rainfall. I mean, even if it's just once a year, in some deserts, that's actually true. Although there is one desert down in, just to let you know, there is one desert down in South America called the Atacama Desert, where we don't. All evidence shows that it hasn't rained there in like 10,000 years. So that's like the driest place on the planet. All right. Anyhow, so as when you have lakes that are always there, not seasonal lakes or seasonal streams, the water table is actually above the surface, right? Because it's where the top of the lake is, or the top of the stream. And streams here, when they talk about streams, they mean rivers too. Okay, so don't get confused about that. So the water table tends to rise and fall with the surface of the topography, the shape of the surface of the earth. That's what that means. All right. So now we need to talk about what are called aquifers. So that these are regions of basically reservoirs of groundwater. So aquifers are really important for the United States and for countries around the world, because you don't have like the Great Lakes sitting right next to you to have access, or we're fortunate in the upstate. If you live in Anderson or Pickens, or Oconee County, you're relatively close to the lakes. Hartwell and Jocassee and Kiowa, right? So there's plenty of fresh water available, but that's not everywhere, right? There's all sorts of places where there's not a huge open lake, and so a lot of times they use these aquifers to get sources of water. Fresh water, of course, we're talking about fresh water. Aquifers generally have high porosity, right? So they're going to store lots of water, and they also have high permeability. In other words, the water can move, which is actually really important, because you don't want stagnant water, right? Stagnant water, if you've ever done any hiking or anything like that, and you find yourself without water, you don't ever drink stagnant water, right? Because it's got all sorts of nasty biological activity going on that your body will definitely reject. All right, so anyhow, that's a different story. Aquifers underline the land surfaces in many areas. It's important to keep in mind that this vital source of fresh water is clean, and we want to maintain it being clean and contaminant free. That's actually very important. There's all sorts of laws and stuff to keep it safe. That doesn't mean that always happens. Perched. Okay, so perched water is. Let me get a picture of this. It often occurs in these discontinuous low permeability layers. So you have to have a layer where the water is not flowing from one layer to the other. And here, it's so much better to look at a picture of this. Now, let's see if there it shows it. Okay, I just should have looked in the next slide. All right, so see, this is kind of like on a perch. Right, a perch, like think about a bird on a perch. It's just sitting there on a ledge or something like that. But this is an actual aquifer, and so beneath that there is some kind of soil that has low permeability. Otherwise, if it was high permeability, this water right here would flow into this other source of this other aquifer. All right, so this is its own aquifer right here. And often these perched water tables will, because they're near a hill or the side of a mountain, there'll be some crack or something where this will flow outward. Sometimes there's even a little waterfall right there, or even a bigger waterfall. All right, so let's see, did I cover everything for that? Personally, discontinuous. Yeah. All right. So I think the picture is really, really helpful. So of course, there's the main water table, and this is its own. This perched water table is above it. Perched is just literally means it's above it. And the only reason it can be like that is because there is this low permeability layer of soil underneath it that's basically holding the water. It's not seeping through. All right, so let's see. Let's read this question. So there's a soil with rounded particles of similar size will have higher porosity than soil with rounded particles of various sizes because. All right, so remember we're thinking about it's the ability of the soil to hold on to the water. It'll have a higher permeability. No, because that's something different. Water flows more easily through rounded rocks. That might be true, but that's not. That doesn't give us that. That's not why it's higher porosity. The smaller segments, smaller segment grain will fill the open pore spaces between the larger grains. In other words, that exactly sounds right. Let's read the last one. Poor sorted sediments will have more open pore spaces. Okay, so poorly sorted. I mean that's certainly true, but the smaller sediment grains that fill the open pore spaces between the larger grains. So that's why it's going to have higher porosity, right? Because that's going to cause it to the soil to trap the water more easily. So C is going to be the correct answer. All right. So let's see. The elevation of the water table. Okay, so this is this we're going to get a little there's actually